In this lesson, I'll show you how to solve first-order linear differential equations. This is part 2. Now, before we start tackling questions 1 and 2, remember that a first-order linear differential equation can generally be written as dy over dx plus py is equal to q, where p and q are functions that are exclusively in terms of x only. In question 1, they want us to solve y prime plus y times cotangent x is equal to cosecant x. Notice that this equation does not have dy over dx, so our first stop will be to change y prime into that. Let's go ahead and do that. We have dy over dx plus y cotangent x is equal to cosecant x. From here, it's very obvious that p is equal to cotangent x and cosecant x is our q. So this is our p and this is our q. And it's important that you identify your p, because once you've identified your p, you can find your integrating factor, and the formula for the integrating factor is shown right here. Once we find our integrating factor, our r, we'll take that and multiply our differential equation by it. Here's what I mean by this. Let's start by saying r is equal to e to the power of the integral of cotangent x dx. Now we have to find the integral of cotangent x dx, and that is a common integral. In fact, it is equal to ln absolute of sine x. The proof won't be shown in this video, but you can always try to integrate it on your own. Now, if the integral of cotangent x is equal to that, and we raise ln absolute of sine x to the base e, we have e to the power of ln. They'll cancel out. So pretend that we had the e here. Given that ln means log base e, this will cancel out with the ln, and we're left with r is equal to sine x. And given that we have absolutes, you can always write the restriction that sine x must be greater than 0. This way we don't need to write the absolutes. Now, as I mentioned, I'm going to take my r value and multiply each of the terms in this differential equation by sine x. Here's what happens if you do that. We have dy over dx times sine x plus this expression times sine x, y cotangent x times sine x is equal to cosecant x times sine x. I want to clear the denominator, so I'll multiply each of these terms now by dx. If I multiply this term by dx, this goes away. We end up with a dx here and a dx over here. This leaves me with sine x dy plus y cotangent x sine dx is equal to cosecant x sine x dx. If I take the integral now of the left side, I'll end up with y times what we found r to be, which was sine x. In other words, if I derive this using the product rule, I'll end up with the expression that we had above. On the right side, cosecant x times sine x, remember what cosecant is equal to? 1 over sine x. So 1 over sine x times sine x gives us 1. So we're taking the integral of 1 with respect to x. The integral of 1 is x plus c. All you have to do from here is solve for c and we're done. And technically you don't even have to do that. This could represent your final answer, or y times sine x minus x is equal to c. That's the answer to question number 1. If you'd like to see the answer to question number 2, and I recommend that you do, please watch part 3 of this series and I'll show you how to answer that.